Okay, so good evening. This is the seventh live discussion session of the course Geotechnical Engineering 1. The topic of today's problem solving session is permeability and methods for its determination. In the previous session, I believe the topic was seepage quicksand condition, if you have attended the previous session. So in this particular session will include only the part dealing with permeability, and I think you have attended some previous sessions of Fridays. But anyway, I'm going to repeat like the previous sessions. This session is also going to have a combination of um, multiple choice questions, multiple select questions, some true false statements, one or two, and some numericals. Okay, so like the previous sessions, again I am going to first dictate all the questions. Okay, and you need to write down the questions one by one. You can write down all the questions as I dictate. And for the numericals, please write down the data very carefully. And I hope you are sitting with your pen, copy, and also a calculator. So after I finish dictating the questions, after you finish writing all the questions, I'll give you some time, 15 minutes approximately, okay, to solve the questions. And when I dictate, when others will join, please don't tell the answers if you know, or write the answers in the chat box. If you know, you can solve it on your own, and you'll get time to uh, let me know about your answers or explanations during the discussion part. So after the time you get for solving the questions, then I will start discussing the solutions, and also I'll explain the concepts behind the solutions. Okay. So without further ado, I'll just start with the session. Again, this is the seventh live discussion session of the course Geotechnical Engineering 1. I'll straight away go to the PPT. Yes. So I hope I'm audible and the PPT is clearly visible. Okay. Please write down the questions very carefully as I dictate them. Okay. The topic is permeability and methods for its determination. This is the seventh problem solving session. Okay. So, just a minute. So, the first question of this session is, yes, seepage velocity is. Seepage velocity is. First option, rate of discharge per unit cross section area of soil. Rate of discharge per unit cross section area of voids. Discharge velocity under constant head. Discharge velocity under variable head. This is a multiple choice question, MCQ. So um, one option will be correct only. And I think I should tell you in the beginning only that today there is a problem with the internet connectivity. It is getting disconnected at times. Okay, so if I get disconnected from the Google Meet, do not disconnect yourselves. Stay in the call. I'll join back right away. Okay. Okay. So seepage velocity is first option rate of discharge per unit cross section area of soil. Second option rate of discharge per unit cross section area of voids. Third option discharge velocity under constant head. Last option discharge velocity under variable head. Okay. Next question is permeability varies approximately. Permeability varies approximately. First option linearly with grain size. Second option as square of the grain size. Third option as cube of the grain size. Last option none of these. I repeat, permeability varies approximately. First option linearly with grain size. Second option as square of the grain size. Third option as cube of the grain size. And last option none of these. Okay, I hope the question was clear. Next question. Yes. Permeability is permeability is first option directly proportional to unit weight of water, inversely proportional to unit weight of water, dependent on both the unit weight of soil and water, or none of these.
Sir,
Hello.
excuse me, sir.
Yes. Yes.
Third option dependent upon the unit weight of soil and unit weight of water or water weight.
No, no, unit weight of soil and unit weight of water. Both
Okay,
unit
sir.
weight of soil and water. It should be
Okay, sir.
weights. Yeah, you're
Okay,
right. It should be weights. Unit weights
okay,
of soil and water. Thanks. Yeah.
okay.
Third option is dependent on both the unit weights of soil and water. Okay, I'll repeat the question. Permeability is first option directly proportional to unit weight of water. Second option, inversely proportional to unit weight of water. Third option, dependent on both the unit weights of soil and water. And last option is none of these. None of these. Okay. Okay. Next question. Yes, this is a numerical. Write down the data very carefully. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is, I repeat, a soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is, first option 12.18, second option 18.18, third option 12.62, last option 18.62. I hope you are familiar with the concepts of discharge velocity and seepage velocity.
Yes, sir.
Yeah.
Sir, this example, will you get a fractions actually?
Will I get a fraction actually?
Did you get a fraction? I don't think fractions will come here.
Yes, fraction will come, I think, because I had solved this. Let me check.
Check it, sir, also.
Yes, yes, fraction will come because I've given the void ratio and not the other thing you are expecting. Anyway, in this kind of questions, if the fraction is a bit, here and there, okay, so
Mm.
this is generally forgiven, in gate, like when the numericals are given and there are not options, then if the answer is suppose 5.5, then as per the model answer, as per the correct answer, you will see that anywhere between 5.2 and 5.8 is correct. Okay, so it's all right, just the technique and the formula, the concept should be clear. We'll do it, don't worry.
Okay.
Yeah. So I repeat the question. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is. Someone has joined. Bhagwan Singh. Okay. Uh, for the person who has joined right now, this is, I believe, this is the fourth question, right? Yeah, this is the fourth question. Please start from here. This is a numerical. The topic is permeability. Okay. So the question was a soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is. Your options are, first one is 12.18, second option is 18.18, third option is 12.62, and the last option is 18.62. Okay. I hope you have written the question. The data, if you write, just like discharge velocity is 6, void ratio 5, sorry, 0.5, seepage velocity is, use the formula and do it, it will be okay. Okay, next question. Yes, in a Darcian flow, the flow velocity is, in a Darcian flow, the flow velocity is, first option, actual velocity, second option is the discharge velocity, third option is the seepage velocity, last option is none of these. This question, like in one of the previous sessions, I believe, one or two sessions, I was asking for the actual nomenclature, right, and not the general term. So here also, according to Darcy's law, the actual nomenclature of the velocity that is taken in the Darcy's law equation that I have asked over here. The flow velocity, what is the flow velocity called in the Darcy's law? Okay, I repeat the question. In a Darcian flow, the flow velocity is, first option, actual velocity, second option, discharge velocity, third option, seepage velocity, last option, none of these. So there are one, two, three. Okay, so someone has joined now. This is the fifth question. In a Darcian flow, the flow velocity is, the options are actual velocity, discharge velocity, seepage velocity, or none of these. Okay, please write down the question from the current one. Okay, next question. For stiff clays, the permeability is determined by, for stiff clays, the permeability is determined by, the options are constant head test, variable head test, capillary permeability test, or consolidation test. I repeat the question. For stiff clays, the permeability is determined by first option constant head test, second option variable head test, third option capillary permeability test, and last option consolidation test. Okay, next question. Laboratory methods for determination of coefficient of permeability include. Here I am asking about the general laboratory methods, and I have not mentioned over in this question, and I'm asking, but still I'll just mention, I'm asking about the direct tests, okay, not the indirect ones. Laboratory methods for determination of coefficient of permeability include first option constant head test, second option pumping in tests, third option variable head test, last option consolidation test. Please keep in mind this is a multiple select question, so more than one option can be correct. You have learnt about these tests, right? Constant head, variable head, pumping in, consolidation tests. There's another one, pumping out tests, I think. Have you learned about these things or have you heard about these tests?
Yes, sir.
Yeah. Again, like the previous classes, I think only one person is responding. Anyway, okay. I repeat the question. Laboratory methods for determination of coefficient of permeability include first option constant head test, second option pumping in tests, third option variable head test, and last option is consolidation test. Okay, next question. Yes, at a given porosity, the permeability of coarse grained soils is inversely proportional to the specific surface. At a given porosity, the permeability of coarse grained soils is inversely proportional to the specific surface. Is this statement true or false? if you read the statement very carefully, I think you'll get a hint because it is very obvious. The hint is very obvious over here. Okay, I repeat the question, the statement. At a given porosity, the permeability of coarse-grained soils is inversely proportional to the specific surface. Okay, is this statement true or false? Next question. Permeability is, first option, directly proportional to the viscosity of water. Second option, inversely proportional to the viscosity of water. Third option, independent of the viscosity of water. Last option, logarithmically proportional to the viscosity of water. I repeat the question. Permeability is, first option is directly proportional to the viscosity of water. Second option, inversely proportional to the viscosity of water. Third option, independent of the viscosity of water. And last option, logarithmically proportional to the viscosity of water. Okay. Next question. A soil is said to be impermeable when the coefficient of permeability is. A soil is said to be impermeable when the coefficient of permeability is, first option, less than 10 to the power minus 7 centimeter per second. Second option, less than 10 to the power minus 9 centimeter per second. Third option, less than 10 to the power minus 11 centimeter per second. Last option is less than 10 to the power minus 14 centimeter per second. I repeat the question. A soil is said to be impermeable when the coefficient of permeability is, first option, less than 10 to the power minus 7 centimeter per second. Second option, less than 10 to the power minus 9 centimeter per second. Third option, less than 10 to the power minus 11 centimeter per second. And last option, less than 10 to the power minus 14 centimeter per second. I hope the question was clear. Next question. In sands, Darcy's law is valid and flow will be laminar as long as Reynolds number is less than 2000. Is this statement true or false? I hope you are familiar with Reynolds number and laminar flow and turbulent flow, these terminologies. So there is a condition for Reynolds number both in flow through pipes and flow through soil. Okay, whether it is same or not, that is the main concept of this statement. I repeat the statement. In sands, Darcy's law is valid and flow will be laminar as long as Reynolds number is less than 2000. Is this statement true or false? Okay, so next question. Yes. With a rise in temperature, the permeability, first option, increases, second option, decreases, third option, remains constant, last option is none of these. I repeat the question. with a rise in temperature, the permeability, first option, increases, second option, decreases, third option, it remains constant, last option, none of these. There was actually no other options left. I ran out of options, so I had to give the obvious last option. Okay, please pardon. Anyway, this was the, I think, 12th question. Yes, 12th question. Some more to go. Okay, I'll just go to the next question. Yes, this is, yeah, this is a numerical falling head test. Yeah, falling head. In a falling head permeameter test on a silty clay sample, the following results were obtained. Sample length 12 centimeter, diameter, that is the sample diameter, 80 millimeter, initial head 1200 millimeter, final head 400 millimeter. Time for fall in head is 6 minutes and the standpipe diameter was 4 millimeter. Find the coefficient of permeability in centimeter per second. The first option is 9.289 into 10 to the power minus 5. Second option 9.181 into 10 to the power minus 5. Third option 9.859 into 10 to the power minus 5. And last option 9.478 into 10 to the power minus 5. All of them having unit centimeter per second. You can just write down the data, like if you have the, if you remember the formula, just write the variables and the data. For example, if sample length is L, so L equal to 12, okay, B equal to 80, small d equal to 4, H1 1200, H2 400, T equal to 6 minutes, like this. Okay, I repeat the question. In a falling head permeameter test on a silty clay sample, the following results were obtained. Sample length 12 centimeter, diameter, that is diameter of the sample is 80 millimeter, sorry, 80 millimeter it is. Initial head is 1200 millimeter. Final head is 400 millimeter. Time for the fall in head is 12, sorry, it is 6 minutes. Yeah, time for the fall in head is 6 minutes, and the diameter of the standpipe is 4 millimeter. So in this scenario, what will be the coefficient of permeability in centimeter per second? The options are 9.289 into 10 to the power minus 5, 9.181 into 10 to the power minus 5, 9.859 into 10 to the power minus 5, or 9.478 into 10 to the power minus 5, all in centimeter per second. Okay. Okay. Next question. According to Darcy's law for flow through porous media, the velocity is proportional to. According to Darcy's law for flow through porous media, the velocity is proportional to. Your options are effective stress, hydraulic gradient, cohesion, or stability number. I repeat the question. According to Darcy's law for flow through porous media, the velocity is proportional to. First option, effective stress. Second option, hydraulic gradient. Third option, cohesion. And last option is stability number. Okay. Next question. Permeability in stratified soil deposits show greater magnitude in direction. Permeability in stratified soil deposits show greater magnitude in direction. First option, parallel to the stratification. Second option, perpendicular to the stratification. Third option, inclined to the stratification. Last option, none of these. I will repeat the question. Permeability in stratified soil deposits show greater magnitude in direction. First option, parallel to the stratification. Second option, perpendicular to the stratification. Third option, inclined to the stratification. Last option, none of these. Okay. Next question. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability of the second layer are twice of those of the first, and those of the third layer twice those of second. Let me know if you have any doubt regarding this question. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability of the second layer are twice of those of the third, and those of the third layer twice those of second? That means whatever the value of thickness and permeability it is there in the first layer, the second layer it is twice of the first layer, and whatever the value is there in the second layer, the third layer is twice of the second layer. Okay, so in this case you have to find out the coefficient of permeability in both the horizontal and vertical direction and then find the ratio. So first option is 21/7, second option is 3/7, third option is 18/7, last option is 9/7. Sorry. I repeat the question. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability of the second layer are twice of those of the first, and those of the third layer twice those of second? The options are 21/7, 3/7, 18/7, or 9/7. Okay, I hope the question was clear. Next question. Yes. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross sectional area if a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. So you have understood this is an example of constant head test. Okay, so the height of the soil sample 6 centimeter, the cross sectional area is 50 centimeter square, the quantity of water was 430 ml, time taken for it to pass down was 10 minutes, and the constant head during this passing down of the water was 40 centimeter. So you have to find out the coefficient of permeability in meter per day. In meter per day. First option is 1.53, second option is 1.65, third option is 1.86, and last option is 1.78. The unit should be in meter per day. I repeat the question. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross-sectional area if a quantity of water equal to 430 ml has been passed down in 10 minutes. 10 minutes, wait just a moment. What it is, yeah, 430 ml is passed down, sorry, passed down in 10 minutes under an effective constant head of 40 centimeter. The options are 1.53, 1.65, 1.86, 1.78, all in meter per day. Okay. The last question. Yes, you can take a screenshot of this. A sandy stratum 4 meter thick and having a slope of 3:1 as it is shown in the figure lies between two clay strata which are almost impermeable. Okay, so soil, the part which has been labeled as soil, it is sand. Okay, and below that layer and above that layer it is impervious clay. Okay, two piezometer tubes inserted at 2 points A and B as it is shown over there, and the distance between them is 21 meter, 21 meter apart, and waterhead was noted as shown. Okay, the difference in waterhead is, as you can see, it is 2 meter. If quantity of water per meter width of the sand stratum, width means that is the direction normal to the plane of paper, okay, was observed to be 5 liter per hour. The permeability of the sand strata in meter per second is. So what do we have? We have an inclined stratum. Okay, the thickness is 4 meter. The thickness is 4 meter, and the slope of that stratum is 3:1. Given that between two piezometer tubes, okay, at 21 meter apart, the head difference is shown over here 2 meter. The quantity of water, okay, quantity of water per meter width of the sand stratum was observed to be 5 liter per hour, and in these conditions you have to find out the permeability of the sand strata in meter per second. Okay, so is it clear? The question is clear. I think you have taken a screenshot of this because that is better. If you want to draw the diagram, then it will take some time. Anyway, I'll just wait for another minute. Have you completed writing this question or taking a screenshot of this? Hello? Am I audible?
Yes, sir.
Okay, okay. So I believe there are uh, 18 questions, right? There are 18 questions for those who have joined from the beginning. There are 18 questions. I won't give you 15 minutes because the questions are very conceptual and there are not so many numericals. I'll start at 7:10. Okay, the discussion part. Will it be okay? 7:10.
Okay, sir.
Okay, fine. Hello, am I audible?
Yes, sir.
Yeah, so I hope you have finished solving the questions which I have given. So I will start discussing the solutions now. And if you know the answer, if you have solved the question, you can just unmute yourself and speak. Or if there's any technical issues, you can always write in the chat box too the answer. Okay. Anyway, I'll start the discussion part. So the first question was, yes, seepage velocity is, what is the answer?
Option B, sir.
Yes, option B is the correct answer, because if this is a soil sample, this is the cross section, then we know that it will have soil particles. It will have soil particles. Okay. But the actual flow of water, when we talk about Darcy's law, when we talk about permeability, we calculate the entire area. Suppose this is 1 centimeter. This is 1 centimeter. We'll take the area as 1 into 1, 1 centimeter square. But the soil, the water, okay, or the fluid, any fluid, it is not flowing to the entire cross section. It is flowing through these voids. That is the seepage velocity, rate of discharge per unit cross section area of the voids, and not the entire area of the soil. Okay, this is the definition of seepage velocity. Good. Okay. So just a moment.
Sir,
Yes.
if the question is instead of seepage velocity, if it is a discharge velocity, option A will be correct, sir.
Yes, exactly. If it was
Okay.
discharge velocity, option A will be correct, because that is
Okay.
the general term we use for Darcy's law. Yes.
Okay, sir.
So the next question is, yes, permeability varies approximately. What is the answer? Permeability varies approximately with, how does it vary with the grain size?
Square of the grain size.
Yes, as per Poiseuille's law, I'll just write the Poiseuille's equation a bit later. It varies as square of the grain size, or sometimes it's also called as the effective diameter, as the square of the grain size. So there are many parameters on which the permeability is dependent on, and these parameters are based on Poiseuille's equation and the Darcy's law. Okay, and that includes both the properties of the material through which the water or the fluid is flowing, and also the properties of the permeant, that is the fluid. Okay. So yes, you are correct. Permeability varies approximately as square of the grain size. Okay. Okay. So the next question was, permeability is, now here with the unit weight. What is the answer?
Option A, sir.
Yes, option A, directly proportional to the unit weight of water. Okay. Permeability does not depend on the unit weight of soil. Okay. Does not depend on the unit weight of soil, it depends on the unit weight of water only. That is, here I'm talking about water, that's why I mentioned water. It can be any fluid, whatever. So permeability, yes, you are correct, permeability is directly proportional to the unit weight of water. 9.81 kilonewton per meter cube. Good. So this is the third question. Yes, this is the third question. So next question, A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is. Have you solved this question?
Yes, sir.
Okay, please you don't tell the answer. I want someone else. Dheeraj Raghuvanshi or Bhagavan Singh Lodi. Please, any one of you, have you solved this question? Dheeraj,
Sir, second option 18.18.
okay, second option. And what about uh, Bhagavan Singh Lodi? Have you solved this question?
The discharge velocity.
No, no. What is the answer? Which option?
18.18.
18.18. Okay, fine. Now, how do you solve it? Have you also got the same answer? The one who gave the answer in the beginning? A or B? You got the same answer?
Yes, sir. Actually, answer is 18, but close answer we have chosen 18.18.
Answer is 18.
18.
Okay. How, how have you solved this? Answer is 18.
Which is seepage velocity is the discharge velocity by porosity.
Yes, seepage velocity is discharge velocity divided by the porosity. Okay.
Porosity is 1 by 3.
Porosity is 1 by 3. Okay, you have done it in like 1 by 3.
Yeah, that's all, sir. It is E by 1 plus,
Yeah, E
Yeah.
by 1 plus E, but I have, see, you can also do it like this. See, porosity equal to E by 1 plus E, and that 0.5 by 1 5, what
1.5.
1.5, it can give us 0.33. 1 by 3 it's the correct answer, but in fraction it gives us 0.33, right? In fraction it gives us 0.33.
But
So
if you take 1 by 3, it is inverse, no? So 3 goes to the top. No?
that is the reason I told you that the fraction whichever is the nearest one is correct. So
Yeah, I
since
have.
I have done in this, seeing the example from where I've given this question, so my answer was 18.18. So if you have done in a way, see, zero point 0.5 1.5, remove the decimal, 5 15 1 by 3, easy way to solve this. Okay, but anyway, this is also not correct, not wrong. Your way also it is correct. Okay, so in this way we can get, in this way if you solve it, if v, this is the value of v, right? 6 into 10 to the power minus 7. So this formula is very interesting and important, and I hope you know how this formula is derived. uh, if you don't know, if you can check it any standard soil mechanics book, BC Punmi or Gopal Ranjan Rao. You have to understand the concept why seepage velocity is equals to v by discharge velocity divided by porosity. So yes, in this way if you solve this, the answer will get as 18.18. But 18 if you get, okay, that's also the right answer. So if you get 18, you should go by option B, isn't it?
Yes, sir.
Yeah. So the concept was right. Porosity equals to void ratio divided by 1 plus void ratio, and the value we get, that is the porosity, and seepage velocity is equals to discharge velocity divided by porosity. Okay, the value is in 10 to the power minus 7 meter per second as given in the question. Good. Okay. So next question, just a moment. Darcy flow. Yeah, in a Darcian flow, the flow velocity is, what is it called? The flow velocity in Darcy's law we use in the numericals, general form of the Darcy's law. What is it called? Velocity. Have I got disconnected? No.
No, sir.
Yeah.
I am waiting for other two to answer.
Okay. Okay. Fine. Fine. That's that's very generous of you. But other two are not answering, as I see. They're not willing to unmute themselves.
The option is discharge velocity.
Yeah, that is discharge velocity. It is very easy. Q equals to KIA, we know in Darcy's law, rate of flow, rate of discharge is equals to uh, what is K, coefficient of permeability into I, that is the hydraulic gradient into the area. Now, velocity equals to Q by A, that is KI. This is the definition of discharge velocity, and by A we mean the area of cross section of the soil sample and not of the pores, isn't it? Area of cross section of the soil sample, entire soil sample. Just a moment. This is the problem. OBS does not. Yes, now it has updated. Okay. So yes, in Darcian flow, the flow velocity is termed as discharge velocity. This is the correct answer, option B. Next question. For stiff clays, the permeability is determined by, what is the answer?
The permeability is consolidation test. Option 4.
Fourth option you are saying.
Yes,
Yes.
sir.
Yes, sir. Also, fourth option, sir. Uh, but the falling head may also be used, but I don't know this variable head is similar to falling head or not.
No, no,
Uh,
variable head is similar to falling head, but it cannot be used. I am not going to the discussion of capillary permeability test because it is a very, I have seen a bit difference in the opinion in two different books in some parts. So I'll just ask you to read it. The third option. In constant and variable head, these two cannot be used. These two are mainly used for coarse grained soils. Okay, mainly used for coarse grained soils. For stiff clays, what happens is the coefficient of permeability. Okay, the coefficient it is very less. It is very less, 10 to the less than 10 to the power minus 6 centimeter per second. This is very less because for obvious reasons clay they have porosity but they are not permeable, isn't it? They have porosity but they are not permeable. So in constant head test, this small value of K, that means we have to obtain the discharge will be very less, which might not be able to be we might not be able to measure. Okay, it can be very difficult to measure such a small discharge. And in what will happen in variable head? In variable head, the value of K is inversely proportional to the time of flow. So very low K will give very high time in the falling head test. Okay, that's why. And what happens in consolidation? This is an indirect test. Okay, so when I talk about consolidation, I think there is a in the syllabus there is a chapter. I'm not sure about it, but anyway, I'll say that the coefficient of consolidation is equals to coefficient of permeability divided by the coefficient of volume compressibility into gamma W, that is the unit weight of water. In this way, indirectly using this coefficient of consolidation, coefficient of volume compressibility, okay, and the unit weight of water, we can determine the value of the coefficient of permeability for stiff clays. And because this is very less, the value is very low, we cannot use constant and variable head test. Okay, I hope the question was the solution was clear to you.
Yes, sir. In
Yeah,
the question, small doubt is there for me.
yes, yes,
Why they mention it is stiff clay? Normally, consolidation test is done on a saturated clays, no soft clays.
yes, soft
But why
clay.
they use a stiff clay?
Why they use stiff clay? Because in stiff clay, actually this stiff clay was written more to negate these two options, to negate these two options because they have very less, very less. So this question means the only way to determine the permeability for stiff clays, the highest chances of determination is using consolidation test. Consolidation test is good for saturated clays also, but for stiff clays, the value is so low that there is no chance of using the other three, or very
So,
negligible chance.
yeah, why I asked is, for example, in this
Yeah,
question, if you remove stiff,
yeah.
then answer remains same, na sir. Consolidation test.
Yes, answer remains same, but still,
Mm, mm,
the question can be framed in different ways. I can write saturated clays, I can write stiff clays, anyway. So
okay.
it is not like uh, the specific nature of clay. It is the clay. Okay, I have
Mhm.
written it over here, a specific nature of clay, but the clay is problematic during the other laboratory testing for determination of permeability. Okay, that is known. That's a known concept
Yes, sir.
actually. Yeah.
Yeah.
So the correct option is consolidation test, indirect test, consolidation test. Okay. So next question. Yes, this is with reference to the previous one only. Laboratory methods for determination of coefficient of permeability include which answer or answers are correct?
Uh,
Yes, yes, speak.
Constant head, variable head, and consolidation.
No, I have told in the beginning that laboratory test, direct test should be used. Consolidation test is an indirect test. Okay, so laboratory methods you can see in any
Okay.
standard books they have there under laboratory methods only these two come because this is an indirect test. We will resort to this test only if these two are not working out for in any particular soil sample we obtain from the field. Okay, generally it's a mixture of sand, clay, and generally if we go for these two we can do it, or in pumping in test, pumping out test, that is in the field. But what I'm asking is the direct tests, so these two will be the correct answer. And since I have not mentioned the question the word direct test, I have already told you, right, when I was dictating the question, that you have to mention the direct test and not the indirect ones. Okay, so for that I believe constant head and variable head are the only options. Okay. So laboratory methods for determination of coefficient of permeability include constant head test and variable head test, also called falling head test. Okay. Let me check once. Yes, it is recording. Next question. Yes, at a given porosity, permeability of coarse grained soil is inversely proportional to the specific surface. What is the answer?
So true.
Yes, true. Why true?
Because increasing this specific surface uh, means more fine soil.
Yes.
So yeah,
So what will happen? The soil is more fine. I have mentioned given porosity.
more
So
fine and
if the yes, yes,
so very very less void space.
void space and porosity are
Yeah.
similar terms. So if this particle size becomes finer and finer, what will happen because of this reduction in particle size? The interconnected voids will decrease, because for permeability we don't need voids, right? We need voids which are interconnected, forming a channel. Then only the water can flow smooth, right? So if at a given porosity, we know the porosity is, of the soil is this. Now the specific surface is more. It has more number of particles. And in another soil, with the given porosity, there are less number of particles. What is the meaning of specific surface? Surface area per unit mass, isn't it? So for one type of soil, if there is more number of particles, then because of the interaction between the particles, the interlocking nature of particles in one where the specific surface is more, for example in fine grained soils, okay, then there will be lower chance of obtaining interconnected pores. Okay, if a soil has porosity, if the soil is porous, water is there in the pores, but can the water travel along through the pores? It can only travel under a particular interconnection and arrangement of the particles, because it travels through the pores. Okay, so when I talk about specific surface, and I have already mentioned over here, this was the head, coarse grained soils. Okay, so coarse grained soils, they already have low specific surface, and we know coarse grained soils have higher permeability. For sand, the specific surface for sand, the specific surface is low, permeability is high. For clay, the specific surface is high, permeability is low. So just by using this concept, the answer can be said. But the concept behind this, I just wanted to let you know that at a given porosity it was written. So it is not about the number of voids or the number of pores. It's also about the interconnectivity for the passing of water or fluid to the soil. Okay, is it clear? Any doubt
Yes,
regarding
sir.
this question? Yeah, okay, fine. Sorry. Next question. Permeability is proportional to the viscosity of water. What is the answer?
Sir, second, the permeability is directly proportional to the viscosity of water.
You are telling second, but you are telling directly.
These are
Yes, sir.
inversely proportional to the viscosity of water.
Inversely proportional, right? Yeah. So now I'll write, let me check. Was there any other question with respect to the Poisson's law and Darcy's law combined? I guess no. Okay. So inversely proportional. Now, what was the combined equation for the Poisson's law and Darcy's law? I can write over here because I've already told you the dependencies of the several parameters. Okay. K equal to diameter square into gamma W, unit of water, by viscosity of water, into void ratio cube by 1 plus void ratio into C. C is a constant depending on the particle shape. Okay. So as you can see, square of the particle diameter directly proportional to the unit weight of water inversely with the viscosity of water. Okay. And this is the property of the permeant. When we remove this, so if we divide K by this factor, so means we will multiply by eta divided by gamma W. When you multiply this, that means in this equation we have only ds square e cube by 1 plus e and c. These are the properties of the medium and not the permeant. This is called coefficient of absolute permeability. Okay, this is called the coefficient of absolute permeability, in which we have only the properties of the medium and not the permeant. Okay, this was just something extra I have mentioned. Anyway, in this question, it was asked, how does permeability depend on the viscosity of water? So it is inversely proportional to the viscosity of water. Correct. Okay. Next question. A soil is said to be impermeable when the coefficient of permeability is. What is the answer? Which one is the correct option?
Sir, fourth one seems correct because
I have already mentioned in a previous question that stiff clays has very low permeability, less than 10 to the power minus 6. Okay, 10 to the power minus 7 is the correct answer. Beyond that,
okay.
whatever the value of K we obtained, we don't consider those soils to be permeable at all, because these are very low. This should not be considered. This is the range. This is the maximum, not the range. This is the maximum limit. Sorry, the minimum limit. So if a soil has coefficient of permeability less than 10 to the power minus 7, less than 10 to the power minus 7 centimeter per second. Someone is joining now. Okay, fine. If the value of K is less than 10 to the power minus 7 centimeter per second, then we can say that the soil is practically impermeable. Okay. All right. Next question.
Sir,
Yes.
does these values are as per the IS code or any source?
This was with respect to any source. I have forgotten the source actually because I have
Okay.
only devised the question. So
Mm.
if you want the source, I can check and let you know in the next or upcoming classes. Okay, just
Okay.
remind me once.
No, the reason why I'm asking is
Yes.
each source they can give a different values. No, for everybody there should be some reference benchmark.
No, this is this question I have taken from a question bank, which
Mm.
I believe the source was authentic because the question bank from where I've taken this was authentic. But anyway, since you have
Okay.
raised the question, I will definitely check into it and let you know about the source if I find it. Okay.
Okay, sir.
Yeah. Next question. Just a moment. Recording. Yeah. In science, Darcy's law is valid and flow will be laminar as long as Reynolds number is less than 2000. Is this statement true or false? Anyone?
False. The Reynolds number is less than 2000.
Yes. So what should be the value of Reynolds number if it is false? Less than how much? Or the maximum value of Reynolds number should be how much for laminar flow in sands?
So there are two answers I can interact here.
Okay.
One is normally Darcy's law is not valid in sand except fine sand.
Mhm.
Second thing is Reynolds number should be less than 1.
Yes, less than 1, and by sand you are right, that's his law. If it is not valid, then for the one that for which it is valid, okay, that's his law is valid, it the Reynolds number is how much? Less than equal to how much? 1,
1.
right? Yes, less than equals to 1. What is the formula? So in which case it is 2000 viscosity, in which case it is 2000?
I think it may be for fluids.
No, fluid I understand, but in which scenario of flow? Flow through pipes. When it is flowing through pipes,
Yeah.
in fluid mechanics, when you have learned any fluid is flowing through any pipe or channels, then Reynolds number, if it is less than 2000, that flow will be laminar. If it goes beyond 2000, that flow will be turbulent. Okay. Okay. Next question. With the rise in temperature, the permeability, what happens?
Uh, so increases.
Permeability increases. Why do you
Yeah.
think it increases? Because
Uh, Generally, viscosity
very good,
decreases.
very good, very good, very good. This is the relationship between permeability and viscosity, and this is the relationship between viscosity. What did you say? It what happens? Decreases, right? With rising temperature, what happens? Viscosity decreases. Okay, so temperature increases, viscosity decreases, and viscosity decreases, K increases. So with rise in temp, have I marked the previous answer? Yes, false. Yes. So with the rise in temperature, the permeability it increases. Correct answer. Okay. Next question. Sorry. Have you solved this? Have you solved this question?
Yes, sir.
Second option, 9.181. So, to first find out the area of the sample, pi by 4 d square, that will be approximately 50.27 centimeters square. Okay, area of the standpipe, again pi by 4 small d square, that will be approximately 0.126, yes, 0.126 centimeters square. Okay, now we know that coefficient of permeability equals to 2.303 AL divided by AT log to the base 10 H1 by H2. Okay, small a and capital A, we have just found out what is the value of L. The value of L is the sample length, 12. Okay, what is the value of T? The value of T is time, and time over here is 6 minutes converted into seconds. It is 360 seconds. Okay, 360 seconds. 360. This is 12. What is H1? H1 is whatever you take, 1200 by 400 or 120 by 40, same thing. Solving this, we get approximately 9.181. Yes, 9.181 10 to the power minus 5. The second option. Okay. Falling head permeameter test. Next question. As per Darcy's law, the flow through porous media, velocity proportional to, very easy question, simple question. What?
Hydraulic gradient.
Yes. Velocity proportional to hydraulic gradient. Next question. Permeability in stratified deposits show greater magnitude in direction. Which direction? Which one?
Uh, Parallel to the stratification.
Yes. Why?
Because grain arrangement in such a way uh,
That is
that
okay. Soil mechanics is fine, but try to explain this numerically. Try to explain this numerically. K parallel. What is the formula? If suppose there are n number of layers, so K1 Z1, K2 Z2 plus dot 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 up till Kn Zn, right? Divided by the total thickness, isn't it? Yes,
yes,
right? What is K perpendicular? Total thickness divided by Z1 by K1 plus Z2 by K2 plus up till Zn by Kn. What is this called? Arithmetic mean. What is this called? Harmonic mean, isn't it? So arithmetic mean is always more than the harmonic mean. Arithmetic mean is always more than the harmonic mean. Okay, that's why parallel to certification is always, and of course when it is parallel to certification, as you have mentioned, the obstruction for the flow, if we go again back to soil mechanics, the obstruction to the flow of water or fluid in the stratified deposits is less in parallel and more in perpendicular. Okay, for one particular strata, one particular layer, the soil is moving smoothly, but in the case where it is perpendicular, okay, it is experiencing different layers. All the flow channels, all the flow paths, they're experiencing different layers. But in parallel, each individual flow channel is not experiencing different paths, not paths, sorry, layers. Okay, so it is greater in magnitude, the value of k, when it is parallel to the stratification. Correct. Now, using similar concept, I think you have solved the next sum. Have you solved this? What is the answer?
Last one, sir. 9/7.
Okay, so tell me now, there are three layers, right? So if it is k and value of thickness is z, for the second layer it is how much?
2K1, Z1.
Not k1, it is k actually. There is a comma. Wait.
Okay.
So I'll write it like this: k and z. So it is 2k
2K,
and 2z. For the third layer,
4K, 4Z.
yeah, simple, 4k and 4z. So again, when it is parallel, so k parallel will be equals to how much? K parallel will be equal to how much? Kz plus 2 into 2, 4kz, isn't it? Plus 4 into 4, 16kz. Divided by 4 plus 2, 6 plus 1, 7, 7z. We'll get how much? We'll get, I think, 21 by 7k. 21 by 7k. It can be 3k anyway. Now, k perpendicular. Again, 7z. Then, z by k plus 2z by 2k. Again, z by k plus 4z by 4k. Again, z by k. We get a value of 7 by 3 k. So the ratio k horizontal is to k vertical, k parallel to k perpendicular, yes, will be equals to 21 by 7 into 3 by 7. 3 is a 9 by 7. Okay, any doubt, anyone? Okay, next question. Yes, I hope you have solved this. Very easy. Constant head test. What is the answer? Anyone? Have you solved this?
C, sir. 1.86.
Yes, see. The value of k, if we deduce from the constant head formula, we get volume of water divided by into the length of the sample divided by time into h, that is head, into area of cross section. So that will be equals to, here we have 430, we have the length of the, what is it, 6 centimeter, right? Yes, 6 centimeter. And then the time is 10 minutes, that is 600 seconds. 10 minutes, yes, 600 seconds into 40. What is 40? Constant head is 40 into What is 50? 50 is the area of cross section in centimeter square. 50. Now this entire thing is in centimeter per second. Okay. So convert centimeter to meter. Centimeter to meter. And below it is second. Convert second to days. Convert second to days. Okay. You get 1.86, approximately 1.86 meter per day. Okay. 1.86 meter per day. Yes. Okay. The last question was this one. Have you solved this? Anyone?
3.84 into 10 power minus 6.
Let's see. Yes, you are correct. So this inclined seepage length was the one that was need to be calculated apart from the general formula. So since 21 was the horizontal distance between the two piezometric tubes, okay, and the slope was given 3:1. So if it is 3, this will be 1, that is 21 by 3, 7. So the actual length of the flow, traverse, that is the flow length of the water, will be base square plus perpendicular square root over, that is hypotenuse, that is L, 22.13. Now Q, convert the Q to meter cube. This is in, I guess this is in meter cube per second, right? Meter cube per second, because 1 hour converted into seconds and liter converted to meter cube. This is the discharge. Then again Q equals to KIA. What is I? I equals to H by L. H is the head difference, which is given over here as 2. 2 is the head difference divided by L, the length of traverse, which is 22.13, into area. The thickness is 4 and unit width to the plane of paper is 1. This is the area. Now rearranging this entire equation, we get K equal to 3.8. I think it ranges from 3.82 to 3.84. So even if someone has got 3.82, that might be correct. Okay, please check once. Okay, so 3.84 into 10 to the power minus 6 meter per second. This is the answer you got, right?
Yes, sir. Exactly. I got 3.84.
Yeah. Okay, fine, good. So I believe this was the last of the questions. Yes, this is the last question. So if you have any doubt, you can ask me now, or we can end the session.
Sir, I have a small doubt, sir, related to the layer size.
Layered soil. Which one? Which question?
Yeah, it
Which
was
one?
given in the assignment. I could not solve it still. He has given 3 layers.
This question.
No, sir. It's a similar question. Any question is okay.
Okay, okay. Yeah.
You can use a fresh page of white page and I can tell actually approximately.
Okay, but I don't know if that question you're asking, is that question from the assignment question?
Yeah, similar to the assignment question.
No,
Clue
this
is I need a clue.
no. Yeah, you need a clue, but we are not
Yeah, I'm
allowed
just
to, solve. You can
okay,
you
sir. I
can
will.
take a hint from this question or any other book, but we're not allowed to solve. Actually, we don't. I I don't access the assignment questions at all because
Okay, okay.
I just use my own materials. So
Then I will try, sir. No
yeah,
problem.
yeah. I'm sorry for that, but
Yeah, it's okay. It's okay. Understood.
okay. So if there is no other question, I think we can end the session. This was
What
also
is
a
the
very
next chapter you are dealing, sir?
Sir,
Next week?
okay. Just a minute. I think Dheeraj is asking something. Dheeraj,
yeah,
Raghuvanshi, you
sir,
have any question?
just yeah, sir, just not a question, just general thing. That
Yes.
next Friday maybe a holy festival. So will this session continue on
Yes,
that?
yes. This is the practice session, so no holiday for practice sessions, unfortunately.
Okay, okay,
Okay.
no issue. Then
Yeah.
I have to be prepared in that way.
No, no worries. You will get the solved PPTs and the lecture videos online also. So if you are not there, no worries. But then learn from the videos and the solved PPTs again. Okay, if you're not there.
Okay.
Sir, what is the next chapter, sir? Next week?
Next chapter. Wait a moment. Week 7. This was the 7th week, right? So I think it is stress in soil. Yes, stress in soil.
Okay, sir.
Next chapter is flow nets and stresses in soil from surface loads. I think flow nets have been covered in soil in flow through soils, right? The chapter name is like this, so I have to incorporate something from flow net. I'll see if I have something incorporated. But the chapter will be mainly focused on stresses in soil from surface loads. Okay.
Okay, sir.
Okay, fine. So again, thank you for this interactive session. I will see you again on the coming Friday with the 8th live session. Okay. Thank you.
Thank you, sir.